friends, welcome back to Team Education. Now in this video we are solving the problems based on double integral. That too we are finding the limits for the given region. For example, the first problem you observe, evaluate double integral over R f of x comma y dx dy over the region R, that is positive quadrant of the circle x square plus y square is equal to a square. X square plus y square is equal to a square. So here region they are given, but they are not given limits. So here remember in the previous videos we discussed the type 1. Whenever the limits are finite, model 1, just I have divided the problems in type 1, type 2, type 3 like, okay na? Now type 1 is nothing but when the limits like a to b and c to d, means the limits of x and y both are constant. And type 2 we have like integral a to b, x is equal to a to b, y is a function of f1 of x to f2 of x, or here maybe x is a function of f1 of y to f2 of y, where y is from c to d. So this is type 1 and this is type 2. Now type 3 we discussed in type 3 also we discussed, that is double integral over R f of x comma y dx dy, where R is a region bounded by the circle here. You observe x square plus y square is equal to a square. So if they are not given directly limits, we need to find the limits. Okay, so in this video we are discussing only limits for the given region, because if you know how to find the limits for the given region, then you can solve the these type of the problems very easily. You can solve these type of the problems very easily, right? So the coming to the first problem, evaluate double integral over R f of x comma y dx dy, where the region is positive quadrant of the circle x square plus y square is equal to a square. So the region is what we have, x square plus y square is equal to a square circle, that too positive quadrant. So you see now, suppose if you consider a circle x square plus y square is equal to a square, that is radius a here, right? Radius a. Friends, you observe generally if they are given circles, we can get we know the graph of the circle. Sometimes they will give ellipse, parabola and lemniscate and different cardioid. So if you know that the nature of the curve, then you can draw, then we can find out the limits very easily. Otherwise we have to learn the graph of the functions, graph of this type of f of x comma y functions. How we will learn means in the curve tracing topic you will discuss in the curve tracing. Anyway, they are given here x square plus y square is equal to a square. So this is the circle, that too they are given R is a region bounded by the first quadrant. So this is first quadrant and this is second one and this is third one and this is fourth one. So in the first quadrant, so what I have means only you have this one. So now we are finding the limits for x and y only, that is in Cartesian form. So here you observe this is radius with a, right? So where it is starting when x0 comma y0, origin 2, here you have x is a0 and here 0 comma a, you observe. So this is the region. First octant means generally you have this one, this is the first quadrant of the circle graph. Now this is along with what? First quadrant. So up to this only, this region only you have to take. So in this case you observe x is moving from 0 to a. So x limits are 0 to a. Next y also moved from 0 to a. Suppose if you taken y is also 0 to a. So suppose x 0 to a and y also 0 to a if you taken, then it is the wrong. It is wrong. Why it is wrong? Sir, x is moving from 0 to a and y is 0. That is why you taken x 0 to a. And 0 to 0, 0 to 0, 0 comma 0 to 0 comma a, x is 0. So you choose, here you observe x is 0 to a, y is here 0 to a, it is moving. So it is correct only now. You will think like it is a correct, but it is wrong. Why it is wrong means you observe. So you take the first quadrant, right? In the xy plane. Now x 0 comma 0, x 0, y 0, x 0 comma a means this one, and x a comma 0, a comma 0 is this one, right? This is 0 comma 0 and this is 0 comma a, and a comma a point is this one. Now you observe what you are getting now. If you are using these points 0 0 0 a 0 a, then what you are getting? It is a square. So it is a wrong case. But is it our region is a square? No. Yes or no? It is a wrong case. So what you have to take means one limit should be independent, another limit should be independent. So in this case what you can get means, sir, can I take x is from 0 to a, one case, and here x is independent, x limits are independent, then y obviously dependent on x. So in this case what they are given region that you write down, that is the circle they are given, x square plus y square is equal to a square, x square plus y square is equal to a square. So x is independent. Now keep y is like this only, keep y is left side, then you will have y square is equal to a square minus x square, then y is equal to plus or minus under root of a square minus x square. So here you have two limits, y value is from minus a to y is, here you have, you see, minus square root of a square minus x square to plus square root of a square minus x square, minus to plus you have here, but x is here 0 to a. So in this case what you have to observe means, observe the given region in first quadrant. In the first quadrant x value, y values are what? Positive or negative? Positive only. X is positive, so 0 to a. Y is also what here? 0 only. Y value is also starting from 0. You observe here the y value is what you have? 0. Here y value is what you have? 0. How you can say y 0 means, the region, after getting the region what you have to do means, draw the strip which is parallel to the y axis. Draw the strip which is parallel to the y axis. On this strip here you observe that strip is touches lower limit is what here? Lower curve is what you have? X axis. On the x axis y value is what? 0. So you have to take y is from 0 to which touches upper curve is what you have? Circle. Circle with what here? X square plus y square is equal to a square. X square plus y square is equal to a square value. In the y what you have means, you have two types of y values, that is minus square root of a square minus x square and plus square root of a square minus y square. So plus you have to take, minus you have to take, or both here? Only plus, because that is in first quadrant. That is why here square root of a square minus x square. These are the limits for the region double integral over r f of x comma y dx dy is integral from 0 to a and 0 to square root of a square minus x square f of x comma y dx dy. This is in the first quadrant. Friends, can you guess, if they are given in upper half of the circle, what you will get? In the upper half of the circle, you see, I am solving for this problem only. Upper half of the circle is this one or not here? Generally this is one. Now in this case you observe x started from minus a to a. X is from minus a to a, and y value is this circle. This circle you observe y value on this circle here. You observe here these are y values are y. This is a y line only, na? Yes or no? Y plane y. Sorry, y axis na. On the y axis all the values what you have, first quadrant and the second quadrant what you have? Positive only. So here you have to take x is from minus a to a and y is from 0 to square root of a square minus x square. Are you understood here? In the upper half of the plane what you are getting? Suppose if they are given a full circle means, here you observe like this. If you have total circle, in the total circle what about the x value? Minus a to a. X is lies between minus a to a, and what about the y means? Draw the strip which is parallel to the y axis. In this case you are taking x is a constant limits. Sir, only y you are taking x constant, x is independent. Shall I take y is independent means? Of course you can take y is also independent. If you taken y is independent, what will happen? We will discuss right now. Before that, if the reason is they are given full circle, then what are the x limit and y limit we will discuss. Okay, I will finish that one first. Later we will go for y is independent. So x is from, you observe x started from minus a and with a. Observe this entire region. X is equal to minus a to plus a only. So minus a to plus a for the full circle. What about the y value means? Earlier we are discussing y square is equal to or else y is equal plus or minus square root of a square minus x square you have. So to get the y value, y should be dependent on x na. So draw the strip which is parallel to the y axis like this. So if I draw here the strip, observe this strip. What about the lower curve of this y strip means? That is circle. What is the circle you have? X square plus y square is equal to a square. What is for this curve? For this curve what is the y value means? Minus square root of a square minus x square. And what is the upper curve? Upper curve is this one only na. So for this upper curve, upper circle, okay na, in the first quadrant, circle in the first quadrant, what we have? square root of a square minus x square. So are you understood here clearly? Now you see, I will write for the first quadrant limits, and I will write for the upper half of the circle limits and a full circle. You can understand very clearly. You observe for this integral 0 to a under root this is 0 to square root of a square minus x square. Okay, when this is in first quadrant, and if it is in upper half of the circle, then x is from minus a to a and y from 0 to root of a square minus x square. And for this you have x is from minus a to a and y is from minus square root of a square minus x square to plus square root of a square minus x square. So like this we can find out the limits when x is, if you are taken as a independent. And you will get a doubt also. So what is the doubt means? X you are taken independent. Shall I take y independent means? Yes, you can also take y is independent. In that case, x should be dependent on y. X should be a function of y. So in this case, shall I write directly? So you can, I think you can understand very clearly. So one second, here you see. And what I am taking means, first of all I am writing here limit 0 comma 0 and this is a comma 0 and 0 comma a. For this is the first quadrant. For this, can you guess what are the limits for y limits? Y independent means here y limits means, if you want, you see x is here 0, here also 0. So y is moving from 0 to a. So y is equal to 0 to a, and x limits you want. X is equal to, from where to where it is moving means, this is a circle. X square plus y square is equal to a square. Now I want to write x as a independent of x is the dependent on y. That is nothing but x is a function of y we need to write. So x square is equal to a square minus y square. Then x is equal to plus or minus under root of a square minus y square. But for this first quadrant means, on this first quadrant the value of x is only plus square root of a square minus y square. So are you understood? In the first quadrant what are the y limit? 0 to a and x is 0 to 0 to, only you see here x limit. If you want, draw the strip which is parallel to the x axis. This strip is touches left side on the y axis. Y axis only it touches on the y axis. What is the x value? 0. And right side it touches the circle. What is the circle? X square plus y square is equal to a square. For this circle, in the first quadrant you have x is equal to root of a square minus y square. So you tell me for the upper half of the circle, over now this is upper half of the circle. Now in this case x is independent. Now you have to take here right side of the circle, like this you have to take here. Means in this case you can say y x positive for x greater than 0 in this case. So for this curve you observe y started from minus a to a. Y is from minus a to a. Y is minus a to n. X is equal to, x value is here 0. Right side of x you observe for this curve or this curve you can say 0 to square root of a square minus x square only. So and the total circle if you taken, total circle if you taken, in this case you have y is from minus a to a. Y is equal to minus a to n. X limits you observe. If you want x limits, draw the strip which is parallel to the x axis. In this curve, left side of, for this strip, left side the curve touches this circle. Left side of the circle what you have means x is equal to minus square root of a square minus y square. This is y square only. So minus a square minus y square, and right side you have plus, that is square root of a square minus y square. I think you understood clearly how to evaluate the limits for the given circle in the first quadrant and upper half of the circle and full circle if they are given. Based on this, I will solve the another one also. Please watch this video completely, then you can understand the limits of the circle or else limits of any region very easily. Second problem, R is a region bounded by the first quadrant of the ellipse. X square by a square plus y square by b square is equal to 1. So they are given first quadrant, that is the positive quadrant of the ellipse. X square by a square plus y square by b square is equal to 1. So I am writing now second region limits. Okay. Now graph of the ellipse is like this we have, you see. Not exactly, just I am giving a rough sketch only. So here limits are a to 0 and this is minus a to 0 and this is 0 comma minus b and 0 comma b. Here the ellipse you have x square by a square by y square by b square is equal to 1. So now you observe, if you want first of all, you see first quadrant only they given. First quadrant means like this we have. Now if you take an x is independent and y is independent also, both the cases we will discuss. After that you can write a full circle, full ellipse, or else half of the ellipse, right side of the ellipse. Okay. Now for this I am writing x is independent. So if x is independent is nothing but y is 0 for this curve. Y 0 means x square by a square is equal 1. Then x square is equal to a square. Then x is plus or minus a. But here you observe this is started from 0 comma 0 to a comma 0 only. So x is from 0 to a. And if you want y value, so y should be dependent on x only. So draw the strip which is parallel to the y axis. For this strip, this strip is touches downside on x axis. On the x axis, whatever the y value here, on the x axis y value 0, and right upward what you have means this strip is touches the curve, that is the curve is x square by a square plus y square by b square is equal to 1. So you need to find the y value from this. So you observe x square by a square plus y square by b square is equal to 1 will implies y square by b square is equal to 1 minus x square by a square. So LCM if you taken a square minus x square by a square, then y square by b square is equal to this one. Then y square is equal to b square by a square into a square minus x square. Then here y is equal to plus or minus means you have square root of b square minus a square into a square minus x square. So you can take b square minus a square outside, then you will have b minus y is equal to b minus a times of plus or minus b minus a times of square root of a square minus x square here. But for this strip here, for this curve, this strip is touches the positive quadrant of the ellipse. So in the positive quadrant you have b by a square root of a square minus x square. That's it. Okay. And now we will solve for the upper half of the ellipse. Upper half of the ellipse is like this you have. Okay. Now this is minus a to a. X is from minus a to a in this case. Minus a to a. Now you want y is dependent on x only. So draw the strip which is parallel to the y axis. Here if you written or else here if you written, both will be same you observe. So these two strips, any one of them, both are same only. Because this is here you observe y is a positive in this case, y greater than 0. For this case here you observe this strip touches x axis in the downside. So x on the x axis y limit is what? 0. And what about the upper curve here? Upper curve is this is a this is ellipse of x square by a square plus y square by b square is equal to 1. For this strip here you have y is equal to plus b by a times of square root of a square minus x square. So b by a times of square root of a square minus x square you have. Okay. Next, suppose if they are given full ellipse, tell me you only. Full ellipse if they are given, rough sketch only, don't feel I am not drawing properly. Okay, minus a to a. So here the limits are x is equal to minus a to a, and y limits you want. Y limits means draw the strip which is parallel to the y axis. So for this strip is touches the lower ellipse, that is in the for the lower ellipse you have downside you have so y is equal to minus b by a square root of a square minus x square, and the upper curve you have plus b by a square root of a square minus x square. That's it. So friends, in this case here y is independent we are written. So can you write can you answer for if x is independent for this ellipse? Yes. Okay, you tell me now for x is independent in this case. Now, so what you have to take 0 comma 0, a, this is 0 comma a and a comma 0. So y is independent means here y is started from 0 to a, 0 to a. And what about the x here? In this case you observe x is equal to plus or minus a by b square root of this is b square minus y square, b square minus y square you will have. Okay. So in the positive quadrant, so what you will have here? A by b square root of b square minus y square. Suppose if it is right side of x axis means like this if you have, then in this case you observe y started from minus a to a. Y is independent so y is from minus a to a. Y is equal to minus a to a, and here x is equal to x here you observe draw the strip which is parallel to the x axis. Here also if you draw both will be same here. So left side of the strip what you have means y axis, on the y axis x value 0, and right side you have a by b, this is ellipse of the right side na, a by positive only na, that is b square minus y square. Now you tell me for the full ellipse, x from y from minus a to a, y is equal to minus a to a, you have y is equal to minus a to a. And what about the x limits means x is from minus a by b square root of b square minus y square to plus a by b square root of b square minus y square. I hope that you can understand this one. Okay, this is you understood clearly. Now next one, third problem. R is a region bounded by the parabola y square is equal to x and x is equal to y square here. Here you observe degree 2, the x is equal to y square. Here x square is equal to y, right? X square is equal to y, right? For this, we have to draw the two curves. Here the first curve you have y square is equal to x, y square is equal to x means even powers of y. So symmetrical about x axis, So this is y square is equal to x. How I am saying means by the, this is the property of the curves, tracing of the curves from the, you can get this one. Okay, na? Curve tracing chapter you will discuss graph of the curves clearly. What about the graph which is passing through the origin, tangents of the curves and intersecting, where it is intersecting with the coordinate axis and symmetrical about which axis here. Okay, these all are you will learn in the curve tracing only. Okay, curve sketching or curve tracing. Okay, now y square is equal to x and another curve you have x square is equal to y, x square, so even powers of x, so symmetrical about y axis, here you observe. So this is x square is equal to y. So the reason is intersecting of these two curves, you observe this is the region. So in for this region you want to find the limits here. So here you observe, is it a square? No. So obviously the reason is like will you get limits of this region is will you get like independent? No. One should be independent, another one should be dependent, right? Now for this case here you have to simplify the given curves y square is equal to x and x square is equal to y. So here x is equal to y square, so put here then y square whole square is equal to y. So y to the power of 4 is equal to y you have here. So in this case after simplifying what I will get means y power 4 minus y is equal to 0. If you taken y is a common, y cube minus 1 is equal to 0, then y is equal to 0 comma y is equal to 1. So if you put y is equal to 0 in this curve, what will happen, you see in this parabola if you substitute y is equal to 0, that implies x is equal to 0, and if you y is equal to 1, that implies x is equal to what? 1. So x the points what you can say means 0 comma 0, and this is when x is 1 y is also 1, when x is 0 y is 0, or when y is 0 x is 0. Of course you can cross check with this. You see if y is 0, what is x square? 0, so x is equal to 0. When y is 1, x square is equal to 1, x is equal to plus or minus 1. So you will feel like here plus or minus 1 comma 1, but here you observe that here you observe the region is bounded in the first quadrant only, not the second quadrant. So which one you have to take right now? The limits are here 0 comma 0 points where intersecting these two curves means 0 comma 0 and 1 comma 1, 0 comma 0 and 1 comma 1. So here you have to take one should be independent limit, another one is dependent. So both the regions we will let means x independent limits we will let and y is also independent limits we will let. First of all I am explaining x is a independent limits, x is having independent limits in this case. So when x is independent, so x started from 0 and moved to 1, so x is from 0 to 1. Now I want y value. So y is dependent on x. So if you want y value, draw the strip which is parallel to the y axis. So this is the strip if you taken which is parallel to the y axis. So you observe this is the curve x square is equal to y, and this is the curve y square is equal to x. What is the lower curve for this strip here? Y is equal to x square. This is x limits now. Now y is equal to x square. And what is the upper curve for this strip means here y square is equal to x. So y is equal to u1 na, y is equal to root x. Of course plus or minus root x also correct, but here plus root x you have to write, minus root x you have to write, means that is depends on the quadrant only. So this is in the first quadrant, so you are writing root x only. Next one. Here x is independent you written. Now I want to write the y is independent limits. So in this case you see now again I am writing here, drawing this x square is equal to y strip and x square is equal to y curve and y square is equal to x curve. Now here y is independent. So this is a 0 comma 0 and 1 comma 1. So obviously y is also independent na. So y started from 0 to 1. Y started from 0 to 1. Next I want x limits. So x limits I have to take. X limits I want means what you have to do means draw the strip which is parallel to the x axis. So on this strip you observe left side. What about the left side of the curve for this strip means y square is equal to x. That is nothing but x is equal to y square. Okay now. Now what about x value here you have means for this curve right side of the for this strip is touches the right side, x square is equal to y. So what about the x value on this curve means x is equal to root y plus or minus root y you will get, but which one you have to take means here this one only, plus root y only you have to take. So these are the whenever x is independent limit, whenever y is independent limit. Now we will discuss the fourth problem, region and limits for that. R is a region bounded by the parabola x square is equal to y and x is equal to y straight line here. It is the parabola and straight line x is equal to y. X square is equal to y. X square. So even powers of x. So symmetrical about y axis. Symmetrical about y axis. Next, y is equal to x or x is equal to y. X is equal to y is a straight line which is passing through the origin. Now this is the our region. This is the region. So for this region you have to find the limits. For that you need to solve x square is equal to y and x is equal to y curves. So if you put y is equal to x square, then x is equal to x square, then x square minus x is equal to 0. X if you take in common, x into x minus 1 is equal to 0. So x is equal to 0 comma x is equal to 1. Generally the students will do this x square and this x cancel, so x is equal to 1 only. But here you want to get the two limits, degree 2, so you will have two roots. If you are cancelled, then what you will get means one root only. We will neglect that second root, so you will get to the mistake in that case. Remember, whenever x square is there, the polynomial of degree 2, then fundamental theorem of algebra, you will have a two roots. So one root is here 0, another root is here 1. So put x is equal to 0 in this case. So what you will get means y is 0. That is the point is you have 0 comma 0 when x is equal to 1. This is for x is equal to 0 now x is equal to 1. If you have x is equal to 1, if you substitute, then y is equal to 1 only. So the point is 1 comma 1. So now that both the curves are touches at 0 comma 0, 1 x and 1 comma 1. Now we need to find the limits. One is x is independent limit, another one is y is independent limit. We will discuss two regions, but both the regions limits may be different, but the region is same. Region is the same, but the limits will be different. Okay now. So in this case you can say that is a change of order of integration also. Both we will apply same. Now anyway, here you observe 0 comma 0 to 1 comma 1. For this I want take x is equal to x is independent, so x started from 0 to 1. Next y I want. For that y, what you have to do means draw the strip which is parallel to the y axis. So what about the lower curve for this strip here? You have parabola. What is the parabola means x square is equal to y, so y is equal to x square. And upper curve what you have means straight line. What is the straight line here? X is equal to y, so y is equal to x. That's it. Now next one, whenever y is independent, if you want to take, so y is independent limits means y is started from 0 and moved to 1, so y is equal to 0 to 1. Next I want here what value means here I want the limits of y, and here y should be, sorry, I want limits of x, so x should be a independent limits. So draw the strip which is parallel to the x axis. For this strip left side of the curve what I have means y is equal to x, so x is equal to y, and right side what you have means here that is y is equal to x square, so x is equal to what? Root y, f of x comma y dx dy. That's it. So like this we can find out the limits of the given region. Thank you for watching this video. In the next video we will solve the problems based on this.